So we go to inverse function here. So the inverse of a function, fx, is the function that undo what fx have done. So in mathematics, it is very interesting. After we learn add, plus, then we learn minus. After we learn multiply, after that we learn divide. So after we learn function, now we learn the f inverse. Okay, so the inverse of function fx is written at f minus 1 power minus 1 x. So this is f inverse. So we must know that the domain for f inverse is equal to the range of f, and the range of the f inverse will be equal to the domain of f. Okay, not every function have an inverse. An inverse function f inverse can exist is and only if the function fs is a 1-1 mapping. So we must memorize this one. Only 1-to-1 map, 1-to-1 they have inverse. Okay, not 1-to-1 they don't have inverse. So we have the class discussion. So discuss the function fx equal to x squared. X in real number. Does the function f have inverse function? No. Why? Because it is a many to one function relation. It is a many one mapping. Okay, it is a many one mapping. So it don't have inverse. So how could you change the domain of f so that fx equal to x squared does have an inverse? So the domain of f become the x greater than or equal to 0. Then we have this part only. Then it will become 1-1 function. So now if we have this one, okay, after we cut this side only, okay, so it will become a 1-1 function. So a 1-1 mapping, 1-1 mapping, then it is a it will have a inverse. Okay, so only 1-1 relation, they have a uh, inverse. Okay, so this one. Okay, so we can see that the inverse function is actually square root for this case. So we use this decimals. We have the x squared. Okay, now we limit the domain to the x greater than or equal to 0. Then the square root of x, so we have the square root of x will look like this. And then we have the y equal to x. It is reflected in the line y equal to x. Okay, so for inverse function, okay, actually it is uh, reflected in the line y equal to x. Okay, so we must know this one. Okay, so if we have the x square, then the f inverse. Okay, so we know that the inverse of square is square root ma. So the f inverse of x is square root x. So over here we have fx is x square. Then the f inverse of x is square root of x. Okay, so you can see that the graph is reflected in the line y equal to. So before we go to the uh, work example for inverse, okay, we look at one example. Okay, simple example. So we have a fx equal to 2x plus 3. Okay, so what we will have is something like this. Okay, so when x equal to 1, then it will become 3. 1, then it will become 5. 2, it will become 7. 2 times 2 plus 3, 7. So 0 map to 3, and then 1 map to 5, and then 2 map to 7. So this is the function. Okay, so for inverse function, okay, you must memorize this sentence. Okay, let fy equal to x, then f inverse of x equal to 1. Okay, so for every time when you do the inverse, okay, you must write this sentence. Let Fy equal to X, then F inverse Y equal to X. F inverse X equal to Y. So how to memorize this sentence is something like this. Okay, we have Y here, we have X here. It's something opposite. Normally we have X here, Y here. But to memorize this one, we have Y here, X here. So this one, we map this is the F, and we go back is the F inverse. So we let F of Y is equal to X, then the F inverse of X equal to Y. You can see we sub the Y into F, then Fy equal to X. Then we sub the X into the F inverse, then F inverse X equal to Y. So let Fy equal to X, then F inverse Y, X equal to Y. So this one, Fy is what? Fy will be 2y plus 3. 2y plus 3 equal to X. Then the 2y will become X minus 3. Then Y is equal to X minus 3 over 2. So the F inverse of Y will become F inverse of X is equal to Y. So F inverse of X will become X minus 3 over 2. So you can see that this one go here is F. Now we go back is the F inverse. You have the F inverse of 3. So we substitute 3 inside. Then will become 3 minus 3 over 2, 0. Then the F inverse of 5, then it will become 5 minus 3 over 2. Then it is 1. And we have the F inverse of 7, then it will become 7 minus 3 over 2. Then it will become 2. So you can see that just now the F we map to Fx. Now we use the Fx we map to F. We go back, map it back. So this is the F inverse. 2x plus 3. So we have the 2x plus 3 here. So we have the 2x plus 3 here. And then we have the x divide 2, x minus 3 divide 2. Okay. So you can see that the graph is actually something like this. Okay. So we have the 3 0, then it is 0 3. Okay, so negative 1.50, then 0 negative 1.5. Okay, so we can see that the inverse, okay, the graph of inverse function is reflected in the line y equal to x. Okay, so for this one is something like this. Okay, so we have this one. Okay, so for work example 8, so the fx is this, then we find an expression for f inverse. So like what I said, okay, for the inverse, okay, the first sentence that we need to write is the let, okay, f of y equal to x, then the f inverse x equal to y. Okay, so this is the first sentence to write. Okay, when we do the inverse. Okay, find the inverse. So f of y is square root y plus 1 minus 5 equal to x. Okay, then we have to write y as the subject. So we have the square root y plus 1 equal to x plus 5. Then the y plus 1 is the x plus 5 squared. Then the y will be the x plus 5 squared minus 1. So the f inverse of x is y. So therefore, the f inverse of x is y. Y is the x plus 5 squared minus 1. Okay. So solve f inverse x equal to f35. Okay. So the b here, f inverse of x equal to f35. So f35 is what? Square root 35 plus 1. Okay, wait. So I do it somewhere else. The f of 35 is square root 35 plus 1 minus 5. Then it's 6 minus 5. Square root 36 is 6. then it is 1. Okay, so f35 is actually 1. So the f inverse of x is equal to 1. So we have the x plus 5 square minus 1 equal to 1. So the x plus 5 square equal to 2. Then the x plus 5 equal to the square root 2. Okay, then the x will be square root 2 minus 5. Should be plus minus now, but the one x is greater than negative 1, so it will be this. Okay, but actually for b, we have another method to solve it. That is, we have the f inverse of x equal to f35, which is 1. Then the x will be f1. Okay, we have the f inverse of x is 1. Then inverse we move to this side become f1. So the f1 is square root 1 plus 1 and then plus minus 5. 1 plus 1 minus 5. So minus 5. Then the answer will be square root 2 minus 5. So this is the answer. Okay. So for this one, okay, we have the square root x plus 1. So we have the square root x plus 1 and then minus 5. Okay, square root x plus 1 minus 5. Then we have the x plus 5 square minus 1. So we have the x, okay, wait, we have the x plus 5 square minus 1. Okay, so these two, it look like refracted. Okay, but over here you can see that negative 1, negative 5, negative 1, negative 5. So the graph for the f is something like this. So it's negative 1, negative 5, negative 1, negative 5. And then the graph is look like something like this. So it have negative 1, negative 5. So the x greater than or equal to negative 1 is the domain. So the domain for the function is x greater than or equal to negative 5. And the range of the function is the y greater than or equal to negative 5. Okay, so just now this one I use the reject the negative square root 2 is because we have this one. Then we have the x equal to square root 2 minus 5 and x equal to negative square root 2 minus 5. So this is rejected because the x greater than negative 5. Okay, so greater than or equal to negative 5. Okay. Mm. Yes. Okay. Uh, so for this one, we know that the domain of function is we have a y equal to x here. So we have a y equal to x here. And then this one is refracted. So the one that refracted should be something like this. Okay. So they have something like this. Okay. Then they have the negative 5, negative 1. Okay, so x and y they change their place. Okay, and one side only, so the one behind we don't have. So we know that the domain of the f inverse is equal to the range of the f that is greater than or equal to negative 5. So it is x greater than or equal to negative 5. And then the range for f inverse is equal to the domain of f. So the y is greater than or equal to negative 5 and negative 1. So x greater than or equal to negative 5. So the graph will be this one. We have to add x greater than or equal to negative 5. So this one, just now the domain is x greater than or equal to negative 1. Okay, so this is the graph. This is how the graph look like. Then we have the uh, this point 24 0 and 0 24. Okay, then we have this negative 4 0 0 negative 4, then negative 1 5 negative 5 1. Okay, so this is the graph. This is how the graph look like. Okay, so this is how the graph look like. So it is refracted in the line y equal to x. Okay, so this one is negative 1 negative 5. Okay,